Hello everyone, this is Vinay. I'm going to present about the Q algorithms, which is in data mining. So currently it is a extension of the k-means clustering. So in hierarchical clustering, there are it especially designed for three types. One is large data sets, another is complex shapes, and another one is outlier robust. So coming to the introduction of the Q algorithm. So basically, what is Q? So Q is a clustering using representatives, and it is a based upon the hierarchical clustering algorithm, and it is designed for the large scale data sets and it will detect the complex and irregular cluster shapes. So coming to the key innovations, it is multiple representative points per cluster. So coming to the k-means, it is a single point reference within the cluster. So the extension of the k-means clustering is this Q algorithm. So it not just one centroid captures full shape. It points trunk towards centroid. It's a less outlier noise and it works on the sample data. For example, speed. So basically, why this Q is very important. So the problem with k-means and traditional algorithms is single centroid. So one center point cannot represent the full spread of clusters and shape failure. So it cannot detect the elongated and crescent or irregular shapes. And coming to the outlier sensitive, if one outlier shifts the center, skewing the entire cluster. And coming to the spherical bias, it assumes all clusters are round and real data is rarely dissembled. So basically, in k-means and another traditional algorithms, these are all the disadvantages. So by this, we can say that the pure algorithm represents all this clearly. So how the above problem solved by the Qs? So multiple representatives. So based upon using C points per cluster, it's not just a centroid. We map the actual shape. So coming to the full shape structure, it will represent the points in in the form of the cluster boundary. So coming to the point shrinking, each representative points moving alpha into distance towards the centroid. So damping the outliers. So coming to the outlier reduction, shrinking pulls extreme points inward and reducing the influence on the mergers. So by these four types, we can solve the above problem based using the pure algorithm. So coming to this shrinking formula, the formula for the new point is p plus alpha into centroid minus p. Here p represents original representative point and alpha represents string factor, which is range between 0 to 1. So each cluster is represented by multiple scattered points. So first we need to select the C points, which will spread across this cluster. And we need to string each point alpha into towards centroid and using string points for distance checks. And the distance between the clusters that is equal to minimum distance between their representative sets. And coming to the working overflow, first we need to select the random sampling. First we need to draw a sample to reduce computation. And coming to the second point, partitioning, we need to divide the sample into partitions for local clustering. And coming to the representative points that I have already shown in the boss way, we'll select the C scattered points for each and every cluster. So by using the stringing formula, we need to reduce the each and every towards and right. And after that, we need to merge the clusters. So based upon this, we need to uh, do the representative points that I have shown earlier. So coming to the visual flow, that first we need to select the sampling, like it will reduce the n based upon the sample size and partitioning. So it will split the value into the p small partitions. So we need to check the boundary points first. So that we need C value. That C value can be calculated by using the above formula. And string, by using the stringing formula, we can calculate the new point. And after that, we need to merge the all centroids, all the clusters. So first, we need to take the raw data, which is in the endpoints, and we need to take the sample subset. And after that, we need to partitioning into the samples. And based upon the stringing formula and representative points, we can need to calculate those values. And after that, we need to merge the clusters. So these are the key parameters. First, we need to represent the points. Number of represented points per cluster is called represented points. So which having the higher C value, it will have the better shapes to capture, but more computation. There it will range between 5 to 20. So coming to the string factor alpha, it controls how far each represented points move towards the center. Right? So if alpha is 0 means it will keep the original points. And if alpha is equal to 1 means it will move to the center. So it will ranges from 0 to 1. So coming to the target clusters, final number of clusters are desired. So it will stop the condition of the merge process. It will domain independent because we need to merge the clusters at the end of the stage. So it will target the only merging the clusters. So coming to the handling outliers, first there are five main points to handle the outliers. So coming to the first, we need to how to handle the outlier. First, we need to know what is outlier. If all the points are very together, that one point which is far away from the together point, it is called outlier. So first we need to extreme points get pulled inward and we need to string based upon their reducing the weights. And there is no longer attractive. We need to cluster the merges. And coming to the post clustering, it is very small clusters flagged as outliers. So it is more robust than K-means and DB-scan for noisy data. So it will work only best for the sorted data. So these are the symbol which represent the outliers. Like if it is three arrows which is moving from left to right, it is elongated or linear clusters. So if it is the banana shapes and if it is blob clusters and the fourth one is nested or ring shaped data. The fifth one is the rhombo shape, like any shape with the defined boundaries. So based upon these shapes, you can handle the outliers. So coming to the numerical examples, previously we have discussed about those NKC values. So if they are given n is equal to 10,000 data points and k value is equal to 10 and c is equal to 5, which represent the cluster. So my goal is to compute the time and space complexity of running pure on this data set. So first we need to, first step is calculate the pairwise directions, like pairwise the distance. So after that we need to hierarchy merge the clusters. And after that, we need to select the cluster. After that, we need to string. After that, we need to, at last, we need to merge based upon the following values, K and C. So pairwise distance for we need to calculate is n into n minus 1 divided by 2. So based upon that, we can calculate the pairwise distance. So it is 50 million approximately. So each pair of points is counted once and we divide by 2 to avoid double counting. So every point is connected to every other point. So 50 million is the distance. So coming to the hierarchical clustering, formula is n square into log n base 2. So after calculating n square, we can get some value and after that the hierarchical clustering, the value is 1.3 into 10 power 9 operations. So this is the bottleneck of Cure, the most expensive step by so far because we need to calculate the n square which will take more time like based upon the previous step 1. So coming to the dendrogram, it is a tree-based structure. First, we need to calculate the root value and we need to come to the chains and like coming to the leaf nodes. So after that, we need to clusters, more merge bottom of one k clusters in mind. So coming to the selection process, the formula is n into c, which will represent the 50,000 representative points. So on step 4 is stringing. It is same as counted 50,000 operations that I have calculated at step 3. So each of the 50,000 representative points is moved towards the centered ones. So if you see here in the diagram, so basically this red color represents the selection, and this the the peach color represents the shrinking parts. So at the center is the centroid, and over the center there are some points which will represent both selection and the shrinking. So this is about the selection and shrinking process. So at last we need to merge the clusters based upon the following operations that we have done up to step 4. So after merging the operations, the decision that it will take is n square log n, the dominant term. So the time complexity order of n square into log n. So basically, the final complexity is order of n square into log n. And the space complexity order of n square because we have used the two memory allocations. So the domain cost is hierarchical clustering. So selection and shrinking are negligible by the comparison. So coming to the step operations and cost. So calculating the pairwise distance, we can take the operation of n into n minus 1 by 2 and the cost is 50 million operations. So coming to the hierarchical cluster step, the operations that we have done is n square log n. So in the cluster is 1.3 billion. So in the selection and the shrinking, the same operation we have calculated, that is n into c, which will take the cost as same 50,000 operations, like 50,000 representative points. So coming to the last step margin, If we take the n-square Lion time complexity, n-square Lion operation, the cost is 1.3 billion. So this is how we merge the clusters. So based upon the step 3 and step 4, it will contribute less than 0.01 percentage of the computation. So the merge step dominates. So coming to the conclusion, pure algorithm is a very powerful hierarchical clustering method for real world data. So it will handle the large datasets efficiently via sampling and will index complex and irregular customer shapes. So coming to the robust to outliers through representative point shrinking. So based upon step 4, we can calculate the shrinking part using the formula alpha into C. So coming to the limitations, order of n square log, it has more time complexity. So we can reduce to order of n or order of log n. It is very better for optimizing the pure algorithm. So it will require more parameters like C, comma, alpha, comma, k. Because if you want to calculate these five steps, we need the value of n, k, and c. So here k value is alpha. So based upon these k, n, k, c values, you can calculate those five steps. Thank you.